Hello, my name is Leo Wei, and my serial number is 109511274. Now I'm going to do a report on my project, which is folded cascode operational amplifier. And for this project, my supervising professor will be赵昌博professor, and also my mentor will be Alan Chen. So for this report, I will cover 3 points, which is the elaboration, circuit schematic and design, and also HPI simulation and results. And lastly is the conclusion. So first we're gonna elaborate the folded cascode op amp, which is this is a specific type of op amp topology used to achieve high gain, wide bandwidth, and a high output swing, while maintaining a relatively low power consumption. And for this op amp, the configuration is stacking transistors, which we can see on the left-hand side here. And for the structure, this structure will improve the voltage headroom and also increase output swing. And for this project, this is the circuit schematic and also the design. So on the left hand side is the circuit design, and also for this circuit design, we're gonna need a CMFB circuit, which on the right hand side. And this is the complete circuit schematic, where on the right hand side is the CMFB circuit mentioned before. So the CMFB circuit is connected to the CMS sense and also CMFB point, and which on the right hand side, and the middle is the OP itself, and also the left hand side is the input stage, which the input pairs is gonna be. So for this project or designing procedure, we're gonna follow these 3 phases, which phase 1 is the specification mentioned, which is stated on the slide here. And the phase 2 is find all of the node voltages, simulate all of the MOSFET sizes, and also designing the circuit into HPAS syntax. And the third phase will be the uh, making sure of the MOSFET in saturation region and also meet the specifications. So the node voltages we currently design will be in saturation region, which gonna follow the condition which highlighted here in bold, which is the condition for VGS is stated and also the VDS is stated. And here is the node voltages for the design, which the node voltage stated is following the saturation region stated before. And for the MOSFETs, we're gonna follow the following code and find the and simulate a sweep on the width according to the current stated on the previous slide. And this is the result, where this is an example for MOSFET 1 M1. So at 10 microamps, we're gonna have a 1.5 micrometer for the width. And this is the node voltages and also the region. And for the region, as you can see, all of it is on saturation region, and all of the ID or the current is following the design that we have made before. And for the node voltages and also region, we can create an op.sp and also cmfb.sp using the recall function, and put it on a file called op_dc.sp, which we can simulate and produce the .list file. And also here is the DC gain for the project, and as you can see, it's quite low, 45.7 dB. So therefore, we're gonna need to increase that. And for the phase margin, the phase margin is okay. It is quite it has met our specification, but the UGF or the unit gain frequency is far from our specifications, so we're gonna need to improve that as well. And after the improvement, here is our specification results as stated in the slide, uh, which is here is the output voltage, which is around 900 millivolts, and the region, everything is on saturation, which is in the safe zone. And also we're gonna improve the current into the second version, which we're gonna increase the current to meet our specifications. And for the phase margin, as you can see the calculation, we have a 75.03 degree, which meets the specification, and the UGF also meets the specifications. And the next part is the DC gain, which we have is around for 59.6 or maybe 60 dB, which has increased a lot from the previous version. And also the slew rate is around 32.8, which is the calculation is shown on the slide here. So for the adjusted design, we're gonna adjust, firstly, we're gonna adjust the op.sp, which we're gonna adjust the multiplier, the sizes of the MOSFET and everything. And also we're gonna adjust the multiplier on the SMFB and then put it on the op underscore dc.sp, which we're gonna simulate all of node voltages and region. And then we're gonna have go to the underscore op underscore AC and underscore SR here, which is going to simulate the phase margin, UGF, and also slew rate. So for the conclusion, by following the design procedure, which stated on 6 point here, uh, we're gonna have to adjust furthermore according to the circuit schematic and also the definition of the circuit itself. So by having a knowledge regarding the circuit we're working on will be an additional plus point to have as we do debugging and others. Okay, so that's all for this report. And thank you for my supervising professor, the Tampo professor, and also my mentor, Alan Chen. Thank you.